Hi, welcome to the video solution for physics. This is IAL Physics, Unit 2, October 2017, Part 3. Let's start. Question number 17. The diagram shows some of the energy levels for hydrogen atom. So these lines are showing hydrogen atom with the energy level, and these energies are in electron volt. State what is meant by ground state of an atom. So ground state means lowest possible energy of an atom or lowest possible energy for electron in an atom. Under certain conditions, electromagnetic radiations of a wavelength 122 nanometer is emitted. Determine the transition which would result in emission of electromagnetic radiation of this wavelength. So what is happening? In this condition, we have emission. Emission means electron is jumping from some higher level to the lower level. That's why we have emission of radiation. And the radiation which is being emitted in this transition, we have a wavelength. So what do? Using this wavelength, given wavelength, we find energy of the photon and then compare this energy with the difference of the uh, energies between the levels. So the first step is to figure out how much energy did we get if this wavelength photon is emitted. So E is equal to HF. We don't have frequency, we have wavelength. So we can rewrite this equation as H F is C by lambda. So HC by lambda, meaning H is 6.63 10 to the power minus 34. C is the speed of light, 3 into 10 raised to the power 8, and divided by lambda. Lambda is 122 nanometer. Nano is 10 to the power minus 9. Once you solve these, you will get energy 1. So energy is 1.63 into 10 to the power minus 18 joule. We cannot compare this energy with these because these energies are in electron volt. So we should convert joule into electron volt. And how do we do that? We divide this energy 1.63 10 to the power minus 18 with the number 1.6 into 10 to the power minus 19. This is in fact charge of one electron. And when you divide these, you have energy of the photon 10.2 electron volt. So you need to see which two energy levels will give you the difference of 10.2. Clearly 0, 1.5 and 3. So it's a waste of time if we see the difference between these three, and this is 13.6, this is 3.39. If you subtract these two energies, so you would have 10.2. That means transition from energy level 2 to energy level 1 will give you the photon of 122 nanometer. So you will write answer that from minus 3.39 electron volt to minus 13.6. This is the transition that will give you. And identify the part of electromagnetic spectrum to which radiation of this wavelength belongs. So if you have a picture of electromagnetic spectrum, wavelength is 10 to the power minus 9, and 10 to the power minus 9 meter, this is typical wavelength of ultraviolet UV light. So 10 to the power minus 8, 10 to the power minus 9. These are the range of UV radiation. So you can see that In this case, this is the wavelength, 10 to the power 3, radio -2, microwave -5, infrared -6 or -7 around, visible -8 and -9, ultraviolet -10 is gamma. So 10 to the power -10 falls in ultraviolet. So you have ultraviolet radiation. Question 18. A car has 4 identical side lamps or side lights. They are connected to the battery of the car as shown. This is a car battery, 4 lamps. Drive an expression for electromotive force E in terms of current I and internal resistance R of battery and resistance R of each bulb. So expression for electromotive force EMF, general expression of EMF is E is equal to V plus I R. I guess this is not capital R, it must be small r. Yes, E is equal to V plus IR. This small r is the internal resistance. So you can rewrite this equation as, this is V. This V is the terminal potential difference across the battery or across the external resistances. In this case, we have bulbs. So you can write V as IR plus IR. The problem here is this R should be total resistance of all the bulbs. So this R should be RT, total resistance. That means we need to figure out total resistance of this combination. Suppose resistance of one bulb is R, that's what they are saying. In this case, R, the resistance of each bulb. And how many bulbs do we have here? We have 4 bulbs in parallel. That means 1 upon RT is equal to 4 bulb means 1 upon R plus 1 upon R plus 1 upon R plus 1 upon R. So it is 4 upon R. Again, especially in this case when you are finding total resistance of parallel combination, most of the students do mistakes that they think this is the final answer. Remember, this is not the total resistance. This is 1 upon total resistance. So you need to take reciprocal of this. That means you switch to this, so it becomes R upon 4. So the total resistance is R upon 4. So you replace this R, which is the total resistance, with R upon 4. So EMF would be equal to I times of R, in this case R by 4, plus IR. So this is the expression for EMF. Or if you want to do one more step, it's your choice. You can leave it here or you can do one more step. You can take I common. So final answer should be E is equal to I is common. Inside the bracket you have R by 4 plus small r, internal resistance. So this is EMF. When the side lights are on, the current through each bulb is 0.43 ampere. Calculate the power dissipation in R. Power dissipation in any resistance, you know that this R is the internal resistance and resistance is given. So if you wish to find power dissipation, so formula is P is equal to I square R. So if you have current and internal resistance, you can find the power dissipation. The problem is we have internal resistance, but we don't have current. The current given is 0.53 ampere. This is in each bulb. And if you see the diagram in the question, there are 4 bulbs we are using. That means the total current should be 4 times of this number. That must be the total current. So you can see that from each bulb, let's say 0.43 current is passing, 0.43 and 0.43 and 0.43. So the total current passing through the battery or coming out from the battery is 4 times of 0.43. That means power dissipation in internal resistance I square R. So I is 0.43 square into I forgot to it's 4 times of 0.43 whole square times of internal resistance 0.025, and P is equal to 0.0739. You round it off and say that the power is 0.074 watt. To start the engine, a starter motor is briefly connected in parallel across the battery. The starter motor draws a current of 120 ampere from the battery. Explain why the side lights will dim as the engine is started. This is a common observation. If you sit in the car, turn the side lights on and you start the engine, so the side lights goes dim. The reason is high amount of current during starting is drawn from the battery. So you see a large amount of current is passing through the battery, and the power dissipation is P is equal to I square R. So in internal resistance, due to large amount of current, a lots of power is dissipated. That means a large amount of lost volt inside the battery, so that the terminal potential difference is decreased, so the power of the side light reduces. That's why there goes then. Question 19. A student plots a graph of current I against potential difference V of for a light emitting diode, LED diode. This is the graph. State the measurement that this student should make to plot the graph. Your answer should include a suitable circuit diagram. So it's all about investigation or experiment of current passing through an LED or a diode. So your circuit should contain a diode, ampere meter, voltmeter, variable resistor, and a power supply. Remember, as you see the graph is showing the voltage value greater than 1.5. So you should use battery, not the cell. So how do we draw the circuit diagram? Remember, it is a typical circuit diagram in which we have a 4 components or 5 components. We generally generally ignore the voltmeter initially, and then rest of the components are connected in a closed loop or in a series. So you can say that okay, I should draw here. So this is your diode connected with ampere meter, and then power supply, and then variable resistor, then goes to, and the voltmeter at the end we always connect it in parallel to the component which is being studied. So voltmeter is parallel to the diode. So this is the circuit diagram. And what kind of measurement? So the student is going to measure the voltage and the current for a different values of voltage, amount of current in a forward bias and also in a reverse bias, so we can have a full idea about this behavior. So measurement of voltage and current in forward and reverse bias. BI, determine the resistance of the LED when V is plus 2 volt. So this is plus 2 volt, and if you go from there and then here, so you can figure out amount of current, and using this voltage and then current you can figure out the resistance. So at plus 2 volt your voltage your current is around 215, I guess. So you say that at 2 volt the current is 215 milliampere, and then resistance must be equal to I V by I. So voltage is 2 and then current is 0.215 ampere. I divided by 1000 to ampere. So your resistance should be equal to 9.3 ohm. And state the resistance of the LED when V is equal to minus 0.2 volt. So voltage is minus 0.2 and you see that no current is there because of I equal to 0. So resistance is very high as I equal to 0. So you can say very high resistance, very high. C, the student is told that the LED will be damaged if the current is too large. To avoid damage, the LED is connected in a circuit so that it is in series with the resistors of resistance R to limit the size of the current. With reference to the current potential difference characteristic, state why without the resistors the current through the LED could become too large. It is because when we use diode in forward bias means if you see the negative potential is negative terminal of the battery is connected with the negative, so it is in a forward bias. In forward bias, resistance of diode is very low, so a large due to low resistance a large current can pass through the can pass through the diode and can damage the LED. Okay, the intensity of light emitted by LED depends on the magnitude of current through the LED. 95% of electrons flowing through the LED causes a photon to be emitted. The rate at which photons are emitted by LED is 1.6 10 raised to the power 18 per second. So this is number of photon per second, that means N by T. You can refer these as N by T, number of photon per unit time. Use the graph to determine the value of R that will produce this rate of emission of the photon. Okay, so this is the graph. First of all, 95% of electrons flowing through the LED, that means the current is 95%. So meaning 95% of the current, as per definition, Q by T. And if I ask you to see the number of electrons for a given charge, so number of electron for a given charge n is equal to Q by E. Q is the amount of charge, E is the charge of one electron. So this is number of electrons. That means Q is equal to NE. I can replace Q with NE in this equation. So I can rewrite like 95% of I, it becomes 0.95 of I is equal to Q. Q is NE divided by T. And if you see N by T, number of electrons per unit time or number of photons per unit time. So now I have N by T, I have charge of electron, I can figure out current. So if you rearrange for I, so I is equal to N E by T into 0.95, and N by T is 1.6 times power 18, E is charge of electron. If you plug in all the numbers, so your current would be equal to 0.27 ampere. That means for graph it is, you can say that it is 270 milliampere. So from the graph you figure out the corresponding voltage. So 250 and 270 is there. That means this is your voltage, that means 2.2. So you can use this 2.2 volt and this current to figure out. So yes, you have a voltage of diode. So out of 6, 2.2 is across the diode. The rest of the voltage is for R. That means VR, I'm writing here, VR is 6 minus 2.2, that means 3.8 volt. And I need to find the resistance, so R is equal to V by I. I is same for resistor and the diode, and V is 3.8, so 3.8 divided by 0.27. So resistance of external resistance is 14.1 ohm. With a different value of R, the potential difference across LED is 1.8 volt. The energy of emitted photon is 77% of the work done. 77% of the work done on the electron as it moves through this potential difference. Calculate the energy of the photon. So if you see the voltage and the definition of the voltage. So voltage definition is V is work done per unit charge. In this case, work done per unit electron. And this work done is energy. So this is V is equal to, yes, E by E, you can say that, and then energy would be equal to VE. V is 1.8 times 1.6 into 10 raised to the power minus 19. When you multiply this, so you have energy of electron, which is 2.88 10 to the power minus 19 joule. And the photon energy is 77% of the work done, 77% of this. So energy of photon is 77% of E, meaning 0.77 of E, and E is 2.8. So when you multiply 0.77 with this energy, so energy of photon EP is equal to 2.2 into 10 raised to the power minus 19 joule. This is the energy of photon. Thank you very much. Have a nice time.